My name is Varun Dag, and I'll be telling you about large applications practical. In this lecture, we continue our discussion of Git and some of the advanced concepts in Git. So let's get started. So let's say that you have been editing files and you edit and stage a README file which has been done again. And then you edit a contributing.md file without staging it. So if you run git status command, you once again see something like this. So you will see that the branch is up to date, but changes to be committed are readme because this file has been edited and staged. However, for the file contributing.md, these changes have been made, but the file is not yet staged, and therefore it says that you can add a file or you can remove the contents of the edited file by checking out the version in the repository. To see what you changed but not yet staged, like contributing.md, you can actually run the git diff command with no other arguments. So you can write git diff. So what it will do, it will compare the contributing.md in your working folder which has been edited but not yet been committed with a copy in the repository which has been existing in the repository. So you can actually see it gives certain annotations to the two files, and then it shows what branches of code have been removed and added in one file over the other file. So basically this command compares the file in your working directory with the file in the repository in the working area. If you want to see what you have staged that will go into your next commit, you can use the git diff commands with a staged option, and this command compares your staged changes with your last commit. So if you do git diff staged, you will actually see the comparison between the readme file which has been changed and committed, not yet to be committed but staged, with the readme file which is already in your local repository, and it will show you the changes in one file over the other file. You can also write git diff cached, and it will do the same thing as git diff staged. So you can also skip the staging area while committing a file, and you can see an example. Let's run a git status command, and you can actually see that the contributing.md file is not yet staged for committing, but it has changed. It has been modified. So we can actually do something like this: git commit -a-m with the new message, and what will happen, this is a shortcut of both adding or staging the file and also committing the file. So basically in this case, we don't need to write git add on the contributing.md file before the commit, because of the -a flag includes all the changes in the file, and this is convenient because this flag will cause you to include unwanted changes as well. So we should be careful running the two together, but you can do that. So now we can also remove files from the stage. So removing a file from git, you have to remove it from the track file first and remove it from your staging area and then commit it. So the git rm command does exactly that and also removes the file from your working directory, so you don't see it as an untracked file the next round. So in this case, you simply remove the file from your working directory and it shows up under the changed but not updated category, that is, it is unstaged area if you run the git status command. So for example, let's remove a file projects.md and let's run the git status command, and you can actually see that it will show that changes not staged for commit. Basically this file has been deleted and no changes add to commit. If you run now git rm command and it stages the file for removal. So for example, if we run like this, and then it will actually remove the file, and if we run the git status command, it says changes to be committed, and this file has been actually deleted already, and this is ready for committing to the delete is ready to be committed to the repository, that is removing it from the staging area and also committing it. So another useful thing you may want to do is to keep the file in your working tree but remove it from your staging area. So in other words, you may want to keep the file on your hard drive but not have Git track it anymore. This is particularly useful if you forgot to add something in your git ignore file and accidentally staged it, like a large log file or a file with a .a or .o extension. To do this, we can use the cached option. So we can write git rm cached readme, and this will actually keep the file in your working tree but remove it from your staging area. So we can also rename files by writing git mb file from file2 and something like this. Look at the status, you can see git consider it to be renamed file. So we can actually do git mb read md readme, and what will happen if you run the git status command, you will actually see that this file has been renamed from git readme to git to readme just readme, and this is yet to be committed. And this is equivalent to running something like this, like you can write move command, you can remove the readme.md file, and you can add .readme file. So these three commands are equivalent to running one command with git move, first file, which is from file, and to file. So we can also run git log on projects, and the output of git log would look like this, and you can see it will show the different commits as well as the method when they were held and when they were done, as well as it will show the changes in terms of the version numbers which have been put in the files. So if you need more helpful options, we can put -p, which shows the difference introduced in each commit. You can also use -2, which limits the output to only the last two entries of the commit, and you can actually see it shows only the two entries with the checksum field on the last two commits which have happened on the Git repository. So you can also use a series of summarizing options with git log. For example, you want to see some abbreviated stats for each commit, you can use the stat option, and it will show you some other things like what insertions, how many insertions, how many deletions took place, who deleted, what was the message, and others. And another option is this pretty option. This option changes the log output format to other than default. A few pre-built options are available to use, like one line option prints each commit on a single line, which is useful if you're looking at a lot of commits. In addition, short, full, and fuller options show the output in roughly the same format but with less and more information. So you can run git log pretty online, and you can see that now you can see all the commits in one line with their messages. You can also use format command along with pretty form option, which allows you to specify your own log format output like this. So it will tell you the time, how far away, and the messages fell. Okay. So basically this can be useful when we are writing some script which is parsing the output of the git log command, because it allows us to specify a certain format and it will not change, means it will continue to follow the same format for whatever commits which have happened. So there is one other option which is graph option, and this graph option allows us to actually build a graphical structure which shows the main branch as well as sub branches. I will be teaching you branch and how we can merge different branches shortly, but this is mostly graphically shown, and you can see that there are different commits happened on the main branch as well as on the side branch, and also a merge happened. So all these are possible, and there are also time limiting options like since and until, which allows us to limit the output of the git log command to the last 2 weeks of commits, which will show only and the command works with a lot of formats. For example, you can specify dates also or relative, like 2 years 1 day 3 minutes ago, so it will try to respect these kinds of formats. So there is also a way of undoing a commit, which is basically the idea that if we made a commit too early, and we forgot to add some files to it, then we can actually amend the commit. And you can do that by writing git commit amend. And what this command does, it will take your staging area and uses it for the commit. And you have made no changes since your last commits. For instance, you run this command immediately after your previous commit, then your snapshot will look exactly the same and all your changes to your commit message. So you will only change the message but not the commit itself. So the same commit message editor fires up, but it already contains the message of your previous commit. So you can edit the message the same way as always, but it overwrites the previous commit. So as an example, if you commit and then realize that you forgot to stage the changes in a file you wanted to add to this particular commit, then you can do like this. So this is commit, and then you can say add forgotten file, you stage it, and then you do commit amend, and you end up with a single commit. The second commit replaces the result of the first commit. So this is it. We have used this resource to create the chapter 1 and 2 in this case. I would like to acknowledge my student Neha Sharma for the slides. I'm going to talk to you about the activity in this lecture, and this is continuing from the prior tasks which we have done with Git. So here you can start committing your code. Now you will make some changes to the factorial program and some more changes to it, and then you can stage it by writing the git add command. And then you can use the diff option to see the difference between what has been staged, unstaged, what is not staged, and in your working directory. And also you can check what has been staged and its difference with respect to the repository. You can commit your code again, and we can now run the git log command on certain files, which can tell us what files have changed and what commits have happened in the code. So I would request you to try this out on your own at your own pace on the command prompt to get familiar with the git command. We'll meet in the next lecture. Thank you.